Students, good morning. Today I am going to solve one more problem. The problem comes under the category of steady state flow process. The problem is water at 93.5 degrees Celsius is pumped from a storage tank at the rate of 3.15 into 10 to the power of minus 3 meter cube per second. The motor for the pump supplies work at the rate of 1.5 kilowatt. The water goes through a heat exchanger giving up heat at the rate of 700 kilowatt and is delivered to a second storage tank at an elevation 15 meter above the first tank. The question is, what is the temperature of water delivered to the second tank? The density of water at 93.5 degrees Celsius is 958 kg per meter cube. Moreover, the heat capacity of water is given. It is 4.184 kilojoules per kg degree Kelvin. Now I am going to solve the problem. The picturization of problem is given in this image. Okay students, let us start to solve this problem. The picturization of problem is given here. We have two tanks, tank 1 and tank 2. The water, warm water at a temperature of 93.5 degrees Celsius, 93.5 degrees Celsius. The water is being pumped to the tank 2 using a motor through a heat exchanger. This is the problem. Temperature in tank 1 it is given. Question is, what about the temperature in tank 2? Motor is used to pump the fluid, that is 1.5 kilowatt capacity. On the way, it crosses a heat exchanger where certain amount of heat is being given up. That means amount of heat removed from the water, that is given near about 700 kilowatt. Amount of heat removed from the system is 700 kilowatt. This is given in your question paper. At a temperature of 93.5 degrees Celsius, the density of water is 958 kg per meter cube. This is given in our question paper. Volumetric flow rate of water from tank 1 to tank 2 is given 3.15 to 10 to the power of minus 3 meter cube per second. Moreover, the heat capacity of water is 4.184 kg per kilojoules per kg degree Kelvin. This is also printed in your question paper. Clear? Now I am going to solve the problem to find the temperature of water in tank 2. The problem comes under the category of steady state flow process. For this case, the total energy balance. The total energy balance equation. Total energy balance equation is changes in enthalpy plus contribution of kinetic energy to the total energy. That means kinetic energy of mv square. So total change del v square. Contribution of potential energy to the total energy change mgz. So del z. Clear? Is equal to heat and work interaction. That means amount of heat added or removed in terms of Q. This is shaft work done by the system or done on the system. This is the total energy balance equation for open system or constant pressure process. Now I am going to find one by one. Before entering into this, I am going to find the mass flow rate of water. I am made of mass flow rate of water. Volumetric flow rate data is given. Volumetric flow rate, it is multiplied by density of water. So volumetric flow rate is equal to 3.15 into 10 to the power of minus 3 meter cube per second into density is 958 kg per meter cube. Meter cube gets cancelled. The answer is 3.018 kg per second. Now mass flow rate is ready. Okay, I am going to find out the shaft work done by the motor on the system. Work done on the system. Hence WS is equal to 1.5 minus 1.5 kilowatt. This minus sign indicates certain amount of work done on the system. That's why you put minus So this is equal to minus 1.5 kilojoules per second. 1 kilowatt is equal to 1 kilojoules per second. Next, amount of heat. Amount of heat given from the system. That means heat removed from the system. Amount of heat removed from the system. Q is equal to minus. Since it is heat removed from the system, based on the system, this will be minus the negative quantity. So minus 700 kilowatts. 700 kilowatt. In terms of joules per second, minus 700 kilojoules per second. What next? Contribution of potential energy to the total energy change. Potential energy is nothing but mg del Z. M stands for mass flow rate. Mass flow rate is this one predicted. So 3.018 kg per second into 9.81 meter per second square into del Z 15 meter. Listen, kg meter per second square. Kg meter per second square is nothing but Newton. The remaining thing is meter and rest of the thing is Newton meter per second. So this unit is equal to joules per second. The answer is 444.1 joules per second. 9.5 kilojoules per second. So the answer becomes minus 0.4441 kilojoules per second. One more thing is contribution of kinetic energy in total energy balance. Kinetic energy gets cancelled because there is no flow. Water is being pumped from tank 1 to tank 2 in elevated height. So contribution of kinetic energy is 0. Now I am going to substitute all those things in this equation. So del H is equal to Q minus W minus mg del Z. Q is equal to minus 700 kilojoules per second. Minus 700 kilojoules per second. Shaft work done by the motor, that is minus 1.5. Minus 1.5 kilojoules per second. Minus potential energy. This is 0.441 kilojoules per second. So the answer is 698 minus 698.94 kilojoules per second. 94 kilojoules per second is the answer. Enthalpy change during transfer of water from tank 1 to tank by motor through a heat exchanger. Since this is a open system, constant pressure process, we might be studied dH is equal to dQ. Okay, amount of heat added to the system is directly or exactly equal to changes in enthalpy of the system. dQ is nothing but m dot Cp dt. That means mass flow rate, specific heat and changes in temperature. This changes in temperature means T2 minus T1. T2 is the question mark. T2 is the question mark. T1 is given. Temperature of water in tank 1. Now I am going to find the value of T2. So dH is equal to minus 698 minus 698.94 is equal to kilojoules per second is equal to mass flow rate of water m dot. This one is 3.018 kg per second into Cp of water 4.184 kilojoules per kg degree Kelvin. Rest of the things into T2 minus 366.65 degree Kelvin. So kg gets cancelled, kilojoules gets cancelled, second gets cancelled. Remaining thing is degree Kelvin minus degree Kelvin. So the answer becomes minus degree Kelvin. So T2 is equal to minus 698.94 divided by 3.018 into 4.194. This minus term becomes plus. That is 366.65 degree Kelvin. This term entirely will be Kelvin. Okay, the answer is, what is the answer? Minus 55.4 degree Kelvin plus 366.65 degree Kelvin. The answer is 311. Answer is 311.25 degree Kelvin. Okay, what? In terms of degree Celsius, this will be minus 273.15 degree Kelvin. So the answer becomes 38.09 degrees Celsius. 38.09 degrees Celsius. So the temperature of water in tank 2 is 38.09 degrees Celsius or 311.25 degree Kelvin. That's all. Thank you.